Hi students, welcome to the virtual lab of 2 Physics. Today we will do two more experiments with Vernier. Already we have done one experiment that was to find the volume of a sphere. Today we are going to do two experiments. The first one is to find the inner volume of a beaker, and second one is to find the volume of a cylinder. Okay, all of you write down in your observation notebook aim of the experiment. The first experiment is to find the inner volume of the given beaker. The second experiment is to find the volume of the given cylinder. Okay, and all of you are familiar with this apparatus, Vernier Calipers. As I told you before in the previous video, this is used to measure the dimensions of different objects with more accuracy. It has a least count of 0.01 centimeter or 0.1 millimeter. As you know, Vernier calipers consist of two scales. One is this one, this is the main scale, and another small scale here, okay, that can be slided like this, that is called Vernier scale. And there are two jaws. This is one jaw for measuring the outer diameter and outer dimensions of objects. This one, the upper one, is for measuring the inner dimensions, for example the inner diameter of a beaker. Okay, and one more is there at the back side. You can see there is a strip here at the back side. This strip is used for measuring the depth of a beaker. Okay, today's first experiment is to find the inner volume of the given beaker. For that we need to draw the observation table as it was given in the previous experiment, the same observation table. All of you draw the observation table. Okay, now the next one is observations. All of you write down the observations. First of all, we have to find out the least count of the device, or Vernier constant. For that, what we have to do, keep this jaw touching each other, pressed together. Then you can see here 0 of the main scale and 0 of the Vernier are in the same straight line, so there is no zero error. Okay, and also you can see here there are 10 divisions on the Vernier. The small scale has 10 divisions only, and that 10 division, it is not coinciding with the 10 divisions of the main scale. You can see the magnified view here. See here, this is the Vernier one, the bottom one is the Vernier scale, the upper one is the main scale. Now you can see here that the total 10 divisions of the Vernier is coming here, that is coinciding with the 9th division of the main scale. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9th division of the main scale. The first observation is, all of you write down, 10 VSD. 10 VSD equal to 9 MSD. That is 10 Vernier scale division is equal to 9 main scale division. The next line, therefore 1 VSD is equal to 9 by 10 MSD. 9 by 10 MSD. That is 1 VSD is equal to 0.9 MSD. Okay, next line, that is 1 VSD is equal to 0.9 MSD. Means 1 Vernier scale division is equal to 0.9 main scale division. The next line, 1 main scale division, 1 MSD is equal to 1 millimeter. 1 MSD, main scale, the divisions are in millimeter, so 1 MSD is equal to 1 millimeter. The next line, therefore 1 VSD is equal to 0.9 millimeter. That is 1 VSD is equal to 0.9 millimeter. The next line, least count is equal to 1 MSD minus 1 VSD. 1 MSD minus 1 VSD. That is 1 millimeter minus 1 MSD is 1 main scale division is 1 millimeter minus 1 VSD is 0.9 millimeter. So least count is equal to 1 millimeter minus 0.9 millimeter is equal to 0.1 millimeter. 0.1 millimeter. That is the least count of the device, or it is equal to 0.01 centimeter. 0.1 millimeter is equal to 0.01 centimeter. Means we can measure the dimensions with an accuracy of 1 by 10th of a millimeter. 1 by 10th of a millimeter. Okay, now we'll start doing the experiment. All of you note down the values in the observation table. Okay, first we are going to do the experiment of finding the inner volume of the given beaker. Okay, First we will find the inner diameter of the beaker. For that we will fix the beaker on this jaw to measure the inner diameter. Okay, the beaker is kept here between these two small jaws, and move this one. Move this one and keep it tight, pressing each other. Then take the measurement. Now in the first column in the observation table, it is main scale reading. Main scale reading we can take from here. See here on the vernier, the first division of vernier is coming in straight with which division of the main. That is the main scale reading. And we can see from this enlarged view. See here, this is the first division of the vernier. And this is the reading. It means it is 3, 3.1, 3.2, 3.3, 3.4, 3.5. This is 3.5. So all of you write down 3.5 centimeter. All of you write down 3.5 centimeter is the main scale reading. The next step is we need to find the vernier coincidence. Vernier coincidence means out of these 10 divisions, which one is coming straight with the main scale reading, any one of the main scale reading. Now you can see here, this is not coming straight, but see this one. That is 1, 2, 3, the fourth line. The fourth division of vernier is coming straight with the main scale. That is here. The fourth division is coming straight with the main scale. That enlarged view is here. The fourth division, 1, 2, 3, 4. Fourth division of the vernier is coming straight with the main scale. Fourth division is coming straight with one of the division of the main scale. That is vernier coincidence is 4. Then vernier reading will be multiply this vernier coincidence with the least count. That is 4 into 0.01. That means 0.04. 0.04 centimeter is the vernier reading. Now the total diameter, the diameter of the beaker is add both. That is 3.5 centimeter plus 0.04 centimeter. Adding the main scale reading and vernier reading will give the total diameter of the beaker. That is 3.5 centimeter is the main scale reading plus 0.04 centimeter is the vernier reading. Add both. That is 3.5 plus 0.04. That means 3.54. 3.54 centimeter is the diameter of the beaker. Now we'll find the depth of the beaker. To find the depth of the beaker, we should keep this at the back side, and the strip should be adjusted touching the bottom of the beaker, and we can take the measurement from same area, from here itself. Now the beaker is kept at the back side, and the strip should be adjusted so that it should touch here at the bottom, and we can take the reading from here. Now I am adjusting here, sliding this one until the strip touches at the bottom of the beaker. Now it is touching at the bottom of the beaker, so we can take the reading. This is the reading. From here we can take the reading. Which line of the main scale is coming straight with the first division on the vernier? That is the main scale reading. We can see from this enlarged view. Here you can see the first line of the vernier is this one. That is coming after 5.1. 5.1. So 5.1 centimeter. 5.1 centimeter is the main scale reading. The next column, vernier coincidence. Vernier coincidence means out of these 10 divisions, which division is coming straight with the main scale, one of the divisions on the main scale. You see here, first one is not straight, second no. Now this fifth one, see the fifth one, the fifth line here, this fifth one, the middle one. That fifth one is coming straight with one of the lines in main scale. So that is the vernier coincidence. So write down, all of you, vernier coincidence is 5. Vernier coincidence is 5. Then vernier reading will be obtained by multiplying this vernier coincidence with the least count. That is 0.01 is the least count. Then vernier reading will be 5 into 0.01. That is equal to 0.05. 0.05 is the vernier reading. Now the total depth will be sum of these two. Sum of the main scale reading and vernier reading. That is 5.1 plus 0.05. That is 5.15. 5.15 is the depth of the beaker. Now we can find out the volume of the beaker. All of you see the calculations. Now the next experiment, we will find the volume of the cylinder. Volume of the cylinder the same way. First of all, we need to find the diameter of the cylinder. For that, the cylinder is kept between the jaws at the bottom. Okay, and keep it tight and take the readings. The main scale reading, you can see here, the first line of the vernier is coming with here, that is 2.5, this is 2.5, 2.6. So if you write down the observation table, 2.6 is the main scale reading. Then vernier coincidence, which division of the vernier is coming straight with the main scale division, that is here. You can see this one, that is 1, 2, 3, 4, the fourth division. The fourth division on the vernier is coming straight with one of the divisions of main scale, so vernier coincidence is 4. Okay, then vernier reading will be multiplied by least count 4 into 0.01, that is 0.04 centimeter. Then total diameter will be, add both, that is 2.6 plus 0.04. 2.6 plus 0.04, that is 2.64. 2.64 is the diameter. Okay, now we need to measure the length of the cylinder. Okay, for that purpose the cylinder is kept between the jaw, and again the jaw is adjusted. Okay, and press it. Now we can take the measurements. See here, the main scale reading from this magnified view, the vernier is coming here. We can take, it is 3.5, this is 3.5, 3.5, 6, 7. 3.7 is the main scale reading. 3.7 is the main scale reading. Okay, then vernier coincidence is here. Vernier coincidence, out of these divisions, which one of the divisions of vernier is coming straight with the main scale division, that is this one, that is the sixth one. The sixth division is coming straight with the main scale division, so 6 is the vernier coincidence. Vernier coincidence is 6. Then vernier reading will be vernier coincidence into least count, that is 6 into 0.01, that is 0.06. 0.06 centimeter. Now the total length will be, add both main scale reading and vernier reading. Main scale reading is 3.7. 3.7 is the main scale reading. 3.7 plus 0.06, that is 3.76. 3.76 is the length of the cylinder. Now you can find out the volume of the cylinder by using the equation pi r square L. Pi into radius square into length of the cylinder. Radius we can take from the half of the diameter measured, length is here, so you'll get the volume of the cylinder also. And inner volume of the beaker also is pi r square L. Pi r square L, for that r is the half of the diameter, L we can take from the depth. Depth is the length. Okay, now we'll do the calculations. First we'll calculate the inner volume of the beaker. Here we have the initial observations, that is 10 vernier scale division is equal to 9 main scale division, and 1 VSD, 1 vernier scale division is equal to 9 by 10 is equal to 0.9 MSD, and 1 MSD, 1 main scale division is 1 millimeter, 1 VSD is 0.9 of MSD, that is 0.9 into 1 millimeter, that means 0.9 millimeter. Means 1 vernier scale division is equal to 0.9 millimeter. Then least count is 1 MSD minus 1 VSD, that is 1 millimeter minus 0.9 millimeter, that is 0.1 millimeter. It is the least count of the vernier calipers, and it can be written as 0.01 centimeter. 0.01 centimeter. Okay. For the beaker, when we measure the inner diameter, we got the main scale reading 3.5 centimeter, 3.5 centimeters. Vernier coincidence was 4. Multiplying vernier coincidence with the least count, we have to multiply with 0.01, so 0.04. That is the vernier reading. Adding both of these, that is the main scale reading and vernier reading, that will give the dimension here. Dimension here, it is the diameter, that is equal to 3.54 centimeter is the inner diameter of the beaker. Then when we are measuring the depth of the beaker, we obtain the main scale reading. We got the main scale reading 5.1 centimeters. Vernier coincidence was 5. Vernier coincidence was 5. Then vernier reading will be multiply vernier coincidence with the 0.01. So 0.05. 0.05 is the vernier reading. Now adding main scale reading and vernier reading will give the total depth of the beaker, that is 5.15. So 5.15 centimeter is the depth of the beaker. Okay, these are the observations we obtained for the beaker. Now for the cylinder, when we measure the diameter of the cylinder, we got the main scale reading. 2.6 centimeters. 2.6 centimeters. And the Vernier coincidence was 4, and multiplied by least count we'll get 0.04. Now adding the Vernier reading and the main scale reading, we'll get 2.64. Means 2.64 centimeters is the diameter of the given cylinder. Then when we measure the length of the cylinder, we got the main scale reading 3.7 centimeters. We got the main scale reading 3.7 centimeters, and the Vernier coincidence was 6 was the Vernier coincidence, and Vernier reading will be multiply Vernier coincidence with the least count 0.01, that is 0.06 is the Vernier reading. Now adding these two, main scale reading and Vernier reading, that will give the total length of the cylinder, that is 3.76. Okay, so these are the measurements we obtained from the Vernier. Now we can find the volume. To find the inner volume of the beaker, we can use the equation volume is equal to, the shape of the beaker is also cylindrical, so volume of the cylinder is equal to pi r square L. Volume of the cylinder is equal to pi r square L. Okay, for finding the inner volume of the beaker, we can use the equation of volume of a cylinder, because the shape of the beaker is also cylindrical, that is volume of a cylinder is pi r square L. Pi r square L. We need the inner radius of the beaker. We have the inner diameter of the beaker, that is 3.5. So radius will be equal to 3.5 divided by 2. That is equal to 1.77 centimeters. This is the inner radius of the beaker. Then we can find the volume. Then volume is equal to pi r square L, that is 3.14, into radius 1.77, square of that into length. Length we obtained here. Length means depth of the cylinder. Depth we obtained 5.15 centimeters, that is into 5.15 centimeters. On doing this calculation, inner volume of the beaker is 50.17. 50.17. Unit is centimeter cube. Okay, so all of you write down the result. First result, the inner volume of the given beaker is equal to 50.17 centimeter cube. Okay, then for the next experiment, the second experiment is for the cylinder, to find the volume of the cylinder. For volume of the cylinder also we can use the same equation. Volume is equal to pi r square L. Here also we need the radius. We have diameter 2.64. So radius will be equal to half of the diameter, 2.64 divided by 2, that is equal to 1.32 centimeter. And length of the cylinder we have here 3.76 centimeters. 3.76 centimeters. So volume we can calculate here. Volume of the cylinder is equal to pi r square L, that is 3.14, into radius square. Radius is 1.32. Square of that into length. Length is 3.76. When we do this calculation, the value is coming 20.57 centimeter cube. 20.57 centimeter cube is the volume of the given cylinder. Hence we got two results. The first one is the inner volume of the beaker. The second one is the volume of the cylinder. So write in your record book these two experiments separately. Okay, for that first half of the table you can use for the first experiment, the second half of the table for the next experiment. Okay, thank you.